to be here today. How are you doing? I hope you guys are doing fine. This week we will look at density. We'll be, density of solids, liquid. And I want to quickly say that I'm sure you know this. Density is not the same thing as mass. Let's take a quick recap. When you talk about mass is purely the quantity of matter, an object contains. Just like matter is anything that has weight and occupies space. But back to density. Density is defined as the mass of an object divided by the volume. So if you want to get density of anything, determine its mass. And in determining mass, let's start with solid. Very simple. Use your top part balance, weight balance to get the mass, and you measure if it's a regular object for solid. Just measure the dimensions. What are the dimensions? Measure the length, measure the breadth and the height, multiply with your mathematics. What I'm trying to say is you do stuff like this. If your solid is regular shape, like something like this, very simple, just measure the length, okay? Measure the length, measure the width or the breadth, and measure the height, multiply them, 3 of them. So your volume is going to be length and breadth and height. Very simple. And you get it in your normal units, meter cube especially. And having obtained the mass, density is obtained using mass divided by volume. It's very simple. Okay? But if your solid is a regular object, in that case you can't measure this. In that case, you have to make use of what we call you have water in a container. You get water in a container. If it's an irregular object, ensure to get its mass very simple. You measure like you did for regular object, measure the mass. But to get its volume, that may be a bit. So you have water in a measuring cylinder in a container. You note the initial volume. Let's say that's V1, and you have that object, maybe a stone or whatever thing that is not regular. You attach thread to the thread, and you carefully allow it to be dropped into the container. You hold the thread. By so doing, the level of your water will increase. So that could be V2. So the volume of that object, in this case, I'm assuming this is a stone, volume is going to be V2 minus V1. Alright? And you have determined the mass. And you just go ahead, get the density, which is the same thing, mass divided by volume. Okay, very simple. That's how to determine the mass of a regular object. Quickly, for liquid, because of this teaching, I will take you through a simple practical, but let me just tell you quickly, for a liquid, you look for a measuring cylinder, you measure the mass of the measuring cylinder, have your liquid, pour into the cylinder, note the volume, then now measure the mass of the measuring cylinder and the volume on the top hand balance. Okay? By so doing, you can now determine the mass of the volume, of the liquid rather. So once you obtain that, then you make your simple calculation and you get the density. So let's find out how that is being done practically. Just come with me. Okay, so right now we want to determine the density of our liquid. I have with me 3 liquids actually. As you can see, this is liquid C, I have liquid B. The third liquid we're going to use is what I have in this beaker. Let's call it liquid A. But of course, let me tell you, is water actually. So what I'm going to do is, I'm going to determine the mass of my measuring cylinders while they are empty. And I'll pour my liquid into 3 of them, measure the mass, then subtract, so I will know the mass of the liquid. But I'm going to use equal volume for my liquid, okay? So let's start with water. Let's use maybe 30 cm cube. Let me start with water. Like I said, these are liquid A, but I'm just telling you the secret that is water. So let's find out. Oh, there's a mistake here. I need to find the mass of my measuring cylinder. Sorry. Let's find out the mass of the MC measuring cylinder. This is 42.69 for the mass of for this beaker. 42.69. Okay, gram. That's the mass of this. So let's have water of 30 cm cube there. We now measure the mass again and find out the mass of that quantity of water. Okay? Oh, this is too much. It's a bit more than 30. 30 will be fine. Don't forget I said it has to be equal volume of liquids. Okay? Yes, I think I am there. So this is now 30 cm cube of water. Now I'm going to put it on the topper balance. I want to wait for it to get to 0. Just a minute. Good. It's now at 0.0 now. So now it's at 0.0, so we have it placed there. Okay. Right now I have Right now I have 74.66. That's the mass of the water and the measuring cylinder. 74.66. You know, we subtract to get the mass of water. As time goes on, we'll do that. So that's for our water. Now let's move to liquid. Our second liquid. Let's try liquid C. Now, like we did for the water, let's find out the mass of empty measuring cylinder. This is 47. This is 47.63. That's for our liquid C. Okay? So we now have 30 cm cube like we did for water of this liquid poured into this. Okay, so I think I'm there. It's a bit let's just have just small part of it back into the bottom. Yes. Okay, this is better. So let's now find out what the mass of the measuring cylinder and liquid C will give us. Good. This is 74.11. 74.11. That's the mass of the cylinder and the liquid. Like I told you, we are going to subtract to get the mass of our liquid. So quickly, we do for the third liquid. We are measuring the mass of this while it's empty first. So that's our liquid B. Okay. So for our liquid B, the mass of the empty measuring cylinder is 47.16 grams. Okay. So let's have the same volume. We have been using 30 cm cube, and that's what we're going to use for all of them. Then we'll be able to find out which of the three liquids will float when we mix them. Okay, I'm going to 30, I'm not there yet. 30 cm cube. Alright, good, I think this is fine. Okay, so now we have it measured. This is giving us 72.49. 72.49. That's the mass of our liquid C. Oh, liquid B, I'm sorry. Our liquid B and the measuring cylinder. Okay, good. So having subtracted this, now we're going to calculate the density. But I also want to show to us before we end up this teaching, that we need to understand which of these liquids, depending on their density, which of them will float when they are mixed. So we have liquid A. I told you that one. That's let's see. I'll pour my water here, which is liquid A. Let's mix it with liquid B, and let's find out this liquid B and liquid A. If you look at it closely, even if I shake this, you will observe that after some time, liquid B will, if you look at it closely, liquid B should be floating actually. This is to tell us that liquid B has lower density. Okay, if you look at it closely, you see it's coming up. All right, liquid B has a lower density, meaning that liquid A, which is water, is heavier than liquid B. Okay, don't ask me the name of liquid B, but what's important is that liquid A is heavier than liquid B. So that's that part. Quickly, let's look at liquid water and the other liquid as well. Okay, the other liquid. Okay. Maybe we should look at liquid B and liquid C. Let's see. Obviously, liquid A water is heavier than 3 of them, but let's see what happens between these two. Are we going to have any obvious difference? That may be difficult because their density most likely is very close. So that's why, if you look at it, we can't see any obvious, separation, except maybe if it is left, if it's placed somewhere for hours or for days. But majorly, what we are to clarify is that when you have two liquid of different density and they don't mix, we call it miscible liquids. Once they are put together, they will separate and one will float and the other will sink. Thank you very much. So I wish you all the best. Thank you and have a nice day.